So in this section, we're going to look at factorizing trinomials and solving for x using now different methods, one of which being obviously factorizing into two brackets, the other one being completing the square, and then one other one obviously being used in the quadratic formula. So now basically a trinomial is anything in the form of a x squared plus bx plus c. And usually this can factorize beautifully into two brackets, or if not, we have other methods of trying to solve for what x is. So usually they'll say solve for x, or they'll say find the roots of. The roots are basically the x values that will satisfy a particular equation. So if I said a x squared plus bx plus c is equal to 0 is equal to k, if any x value makes this side equal to 0, that x value is considered to be a solution or a root of that expression. So now let's look at one example where we undergo now factorization. So example 1 would just be 3x squared minus 5x equals 2. So usually when we're dealing with quadratic equations, what we're trying to do is get everything, variables and constants, to the one side, make it equal to 0. That way we can then solve it into two brackets. And if we've got two brackets, that means it's one thing multiplied by another. And the only time when you get two things multiplied together, giving you an answer of 0, is when either one of them is 0 or both of them is 0. And that's how we end up solving for this. So with this one, all we need to do now here is bring the 2 across, and then we end up with 3x squared minus 5x minus 2 is equal to 0. Now we can take this and then it can factorize beautifully to two brackets, like so. And then if you remember the little trick, we look at the signs. So the last sign tells us whether the signs in the brackets will be the same or different. So if it's negative, it means the signs will be different. If the last sign is positive, it means the signs inside will be the same. And if the signs are the same, we look at the first sign, and it tells us what the signs will be. So if it was plus and minus, we'd have minus minus on the inside. And if it was plus and plus, we'd have plus plus on the inside. In this case, it's a minus, so they will be different. So what we're trying to find in here is now factors of 2 that will come in there, factors of 3 that will be the first term of each bracket, and then when you multiply it out, the middle term should give us negative 5, right? So we're going to deal now with factors of 3 and factors of negative 2 that when we put them all together will give us negative 5. So now if I say 3x squared can be broken down into 3x and x, because when I multiply these two together I get 3x squared, and then negative 2 can be either negative 2 and 1 or negative 1 and 2. Now which one of those will give us what we're looking for? At the end of the day we're looking for a negative 5. So if I put a negative 2 here and a positive 1 there, what you find is that negative 3x times negative 2 gives us negative 6x, and then 1 times x will give us a positive x, minus 6x plus x gives us negative 5x, and these are the brackets we're looking for. In that case we can then say, oh, that's perfect. It's this times that giving us 0, meaning 3x plus 1 equals 0, or x minus 2 equals 0. And now we've got simple equations now to the power of 1 where we can just solve for x. So on this side we'll just have, x is equal to, take the 1 across, divide by 3, negative 1 over 3, and this side x is equal to, just take the negative 2 across and get a positive 2, positive 2. And there are our two solutions for this quadratic equation. This is an example now of how we use factorizing to solve a quadratic equation. The one thing that you need to figure out right now is that whenever you look at your equation that you need to solve, look at the highest power of your variable, right? The highest power of your variable will tell you how many solutions you expect to get. This is also called the degree of your expression. So this is an expression of the second degree because the highest power of my variable is 2. And since my degree is 2, I expect to find 2 solutions. If I had an expression of the third degree, I'd expect to find 3 solutions. Okay, let's look at another example now in this case where we would complete the square. So, dealing with now completing the square. So what's completing the square all about? Let's first take a step back and look at where this thing comes from. So if I had a binomial, right, it's 2 terms, so let's say x plus 3, and I squared this binomial, my answer would be the first term squared plus the first term times the second term times 2, so that's 3x times 2, which is 6x, plus the last term squared. So 3 squared is 9. So now, whenever we deal with completing the square, what happens is they normally give us the first 2 terms, and then the whole completing the square part comes in the fact that we need to then find the last part that's missing to give us a perfect square, right? And then that's normally quite chill. All we need to then do is then work backwards. Since we know that, so let's say, for example, I was given x plus, let's say x squared plus 4, right? X squared plus 4x. And I was supposed to complete the square. All I know is that, okay, let's look at this. I've got x squared, 6x plus 9. And what you'll notice is, when you're dealing with a perfect square, the last term will always be the coefficient of the middle term, halved and then squared. So half of 6 is 3, square that, you get 9. So what am I missing here to get my perfect square? Half of 4 is 2, square that is 4. So if I add 4, I've now got a perfect square. But adding 4 changed the value of my expression. So because I don't want to change the value of the expression, I must then minus a 4. So it's basically like adding 0. I made no difference to my expression, but I've got a beautiful perfect square that I can now factorize in between there. And now if I factorize these first 3 terms, I will get a perfect square that looks like that. So that will become x plus, and now in your brackets, the next term will simply be half of your middle or your x term. Because half of this is 2x squared, and on the outside I had a minus 4. So that's basically how you go from now this form to your completed square form, by simply adding half of the x term squared and then minusing that term as well, so that you don't change the value of your entire expression. And that's how you basically go about completing the square. Now let's look at an example of doing this in the case where we need to solve now for x. So let's say we were given the following. 2x squared minus 8x minus 6 equals 0. And they asked you solve for x by completing the square. A very important thing when you complete the square is that, first of all, make sure that the term with the x squared has a coefficient of 1. So I must first divide everything through by 2. So that's going to give me simply x squared minus 4x minus 3 equals 0. Now I'm sort of getting somewhere, okay? So now when I complete the square, all I really worry about are the first 2 terms, the x squared term and the single x term. So I can take this negative 3 to the other side, and then I can just work on this side here. So I pop this negative 3 to the other side, it becomes a positive 3, and then I'm going to try to complete the square with this term on this side here. So like I said before, what we need to do, we need to find half of this term squared. So now remember, this term is not just 4, it's negative 4. So half of negative 4 is negative 2, square that, I get 4. So I need to now add and subtract that amount. So then the next term I'm going to say x squared minus 4x plus 4, which is half of this squared, minus 4, which is half of that squared, so that I don't change the value of my sum, and that's equal to a positive 3. Alternatively, what you could do in the first step is, if you add it on this side, add it on the right. It's an equation. What you do on the left, you do on the right. So then if you do that, and then you end up with a nice looking sum. So if I'd done that, it would look like this now, where I had plus 4 here, I'd also plus 4 on the other side. So that gives me 7. Now I've got a beautiful perfect square here that I can factorize into its brackets. So this becomes 7. This will factorize into x, half of this term, so half of negative 4 is negative 2, that is squared, equals 7. Now I've got something that's squared here equals 7. How do I solve for the x? I can take the square root of both sides. The square root of this side is simply going to be x minus 2. And on this side, square root of 7 is going to just be plus or minus the square root of 7. Very important, never forget. The minute, like I said, when you start off with a degree 2 polynomial, you're going to end up with 2 solutions. Now, if you don't put the plus or minus 7 here, you're going to end up with one answer. And then you lose half the marks for your answer because the other answer wasn't given. So remember the plus or minus 7, and then to solve for the x, I'm simply going to say x equals, take the 2 across, it's going to be 2 plus or minus root 7. So the one answer is going to be 2 plus root 7, the other answer is going to be 2 minus root 7, and those are your 2 solutions. And that's basically how you go about solving things by completing the square. And then the third now way of going about completing a polynomial of degree 2 is by the quadratic formula. So let's take a look at the quadratic formula. So the quadratic formula is something that you use if you couldn't quite find the factors that came in beautifully, and it was like really funny numbers where you'd end up with sometimes irrational answers as your roots. So in that case, we have this formula. It looks a bit horrific, but don't worry, it isn't that bad. Memorize it. Within like 3 days, you should get it, and then you'll be able to use it quite easily. X is equal to minus b plus or minus the square root of b squared minus 4ac, and this entire expression divided by 2a. Now if at this point you're thinking, what on earth are these b's and c's and x's? Last you checked, you only had to do with x and maybe occasionally another y, but now we've got a's and b's and c's and it's getting a bit complex. Relax, take a deep breath. It's simply from the general formula of your trinomial, which looks as follows. So you'd have, remember like I said before, ax squared plus bx plus c. So all these values there are taken from this expression. So if I've given you, for example, now an expression that looks like 3x squared minus 2x minus 4, my a value is 3, my b value is minus 2, my c value, is minus 4. So that's how you simply get these. And it's simply, you just read them off and then plug them into the equation. The nice thing about this is you don't have to spend time finding all factors. This one works for every single quadratic equation. It's just that it takes long to sort of solve for this entire thing. But it'll work every single time. So if you do get stuck and you're not sure whether you should use completing the square or find the factors or anything in between, go to the good old formula. It'll work every single time. It might take a bit longer, but you'll get the correct answer. Okay, so now let's try, for example, now if I'd given you this one, let's try solve now for the x values that will satisfy this equation. So then simply we say x is equal to minus b. So b is negative 2, minus b will simply become 2 plus or minus the square root of b squared. Negative 2 squared becomes 4. So we put the negative 2 squared minus 4 times a. A is 3 times c, which is a negative 4. Put all that across there, divided by 2 times a, which is 2 into 6. And then this will give us two answers. We're going to say 2 plus that divided by this, and 2 minus that divided by that to get two answers. So let's quickly find the answer for that. So my one answer becomes, I'm going to write this now in decimal form, 0.768, and then my other answer, I will call that x subscript 2. What I need to do is now change the plus to a negative, and then I end up with negative 0.434. And it's as simple as that. So now that you've seen the three different ways of sort of solving our quadratic equations, go give it a try some examples, try some of the multiple choice questions, see how it works out for you, and then hopefully you'll get this quite well afterwards.